Hi, welcome children. Welcome to another video. Today we are going to discuss few important another beautiful questions. Let's enter into the discussion. Yes, the first question we have crystalline form of borax. It is about borax. It is about the structural details and characteristics of borax. Okay, crystalline form of borax has four options given: tetranuclear unit, all boron atoms in same plane, equal number of sp2 sp3 hybridized boron atoms, one terminal hydroxide per boron atom. So you must know the details of borax. That is the point. So what are the details of borax, characteristic features of borax? First of all, what is basically borax? Borax is Na2B4O7 10H2O. This is borax, the so-called tin-called powder, borax, Na2B4O7 10H2O. Also written as Na2B4O5OH 4 times 8H2O. That is another way of writing borax. Na2B4O5OH 4 times 8H2O. And that can be represented in the linear format like this: Na plus O minus, boron, oxygen, boron, oxygen, boron, oxygen, like this. How many boron? 4 boron. 1, 2, 3. One more boron and oxygen. This is the linear format where each boron you can give OH. This is the linear format of borax. In fact, it doesn't exist like this in the linear format, such a long chain. Definitely we'll go for a cyclic system. It's giving a cyclic system of arrangement, and the original structure we can understand this way. This is the structure of borax in fact. Like this. Each boron will get a OH. This is what borax structure in the cyclic format. You see, there is a tetranuclear unit. There is tetranuclear unit. Definitely, it's a correct answer. It is a correct answer. There is tetranuclear unit. This is nuclear center 1, nuclear center 2, nuclear center 3, and nuclear center 4. Tetranuclear system based on the boron center. Option A is correct answer. All boron atoms in same plane. All boron atoms in same plane. No, they are not in the same plane. You see the type of hybridization that is coming. What is the type of hybridization? This boron is sp2 hybridized and planar. This is sp2 hybridized and planar. While this is also sp2 hybridized and it is planar. While this is sp3 hybridized and is tetrahedral. Tetrahedral. This is also sp3 hybridized and it is tetrahedral. So option B is a wrong statement. This is correct. All boron atoms in the same plane, not in fact. Okay. Option C, equal number of sp2, sp3 hybridized boron atoms. Yes, there are 2 sp2 and 2 sp3 hybridized boron atoms. One terminal hydroxide per boron atom. That is also true. Each boron contain one OH group. Each boron contain one OH group. That is also true statement. And that is about the structural entity of borax and its characteristics based on which we have a question. Right? Fine. Next question. So the answer for the question, except B, All are correct answers. Next. The nitrogen containing compound produced in the reaction nitric acid with the P4O10 can also be prepared by the reaction of P4 and nitric acid, diamagnetic. So we want to know the compound obtained when the nitrogen compound obtained when nitric acid treated with the P4O10. What is the reaction? Nitric acid HNO3 interacting with the P4O10, which is an excellent dehydrating agent. I think many of you are aware of. You get anhydride of nitric acid. N2O5 is the product obtained, plus HPO3, metaphosphoric acid. So, nitric acid when treated with the P4O10, P4O10 is an excellent dehydrating agent. You will get N2O5. N2O5 called the anhydride of nitric acid. So, this is what the compound obtained. Now look at option A. It can also be prepared by reaction of P4 with nitric acid. What is the reaction of P4 with the nitric acid? P4 interacting with the nitric acid. Phosphorus is oxidized to H3PO4 and nitric acid is reduced to NO2 along with the formation of water. So here you are getting nitrogen dioxide. So option A is wrong. What commented is N2O5 is obtained by that reaction. No. You get nitric acid with P4, you get H3PO4 and NO2. Nitric acid is reduced to nitrogen dioxide. Right? So first choice is wrong. Now this compound is diamagnetic. Yes, it is diamagnetic. N2O5 is diamagnetic. Because it doesn't contain any unpaired electron. Look at the structure of N2O5. This is the structure of N2O5. NO like this. You can have two resonating structures. Anyway, this is the one structure where you can find the lone pair of electrons like this. There is no odd electron system. There is no odd electron system. It is all single electron system, paired electrons. And you can see the number of lone pairs is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lone pairs. 12 lone pairs. Even without counting that, you can comment as many nitrogen, 1 each lone pair. 2 nitrogen, 2 lone pair. Oxygen, 5. 5 into 2, 10. 10 plus 2, 12 lone pairs in N2O5. It is not paramagnetic, it is diamagnetic. Now, it contains one NN bond. There is no NN bond. There is no NN bond. As you can find, it is NON bond. There is NON bond. It is not having any NN bond. What next? React with the Na metal produces a brown gas. Reaction with the Na metal. This reacting with the metallic sodium. Metallic sodium reacting with the N2O5. You will get sodium nitrate liberating brown colored NO2 gas. That is a true statement. So option B and D is the correct answer. B and D is the correct answer. A is wrong, as you don't get N2O5, you get NO2. C is wrong, there is no NN bond, there is NON bond. Meanwhile, almost all other oxides of nitrogen contain NN bond. Okay, fine. Next question. The pair of coordination complexes or ions exhibiting same kind of isomerism. Same kind of isomerism. Option A, you don't find any type of isomerism because it is 5 ammonia and chlorine. You don't find any special kind of isomerism there. While in the second compound, here you have geometrical isomerism. So in the first compound, no significant isomerism, while the second compound give geometrical isomerism, as it is 4 ammonia and 2 chlorine, right? Coming to, so option A, it is not the answer. We want the same kind of isomerism performed in both the molecules. Option B, here you can have geometrical isomerism as it is MA4B2 type. Here also you can have geometrical isomerism because it is platinum, 2 ammonia, 1 water and chlorine. So here you can have cis and trans. Here also you can have cis and trans. So same type of isomerism experienced in option B. Okay. Option C. COBr2Cl2. COBr2Cl2. This is tetrahedral complex. This is tetrahedral complex. Therefore, no geometrical isomerism. No geometrical isomerism. While this is square planar complex. This is square planar complex. There is geometrical isomerism, cis and trans. PTBr2Cl2 will give cis and trans isomerism. Anyway, here it is ruled out as this is a tetrahedral complex. Coming to option D. See, here we have 3 ammonia and nitrate with the chlorine. They can show ionization isomerism, isn't it? They can show ionization isomerism. Chlorine and nitro can make an exchange inside and outside the coordination sphere. It can give ionization isomerism. What about here? Here also ionization isomerism possible. Here also ionization isomerism possible. Chlorine and bromine can exchange. So that is an answer. So the answer is option B and D. In option B, both the molecules can perform geometrical isomerism cis-trans combination. While in option D, both can show ionization isomerism. Fine? Yes. Next. And that is the last question in this video. See that question. A substance APBQCr has a cubic close packed arrangement CCP. CCP means FCC of C. So CCP is formed by C, in which A atoms occupy 1/8 of tetrahedral void and B atoms occupy half of octahedral void. What is the molecular formula of the compound? You see, we have A, B and C. C makes FCC. C make FCC means it is particle present at the corners and center of the faces. Particle present at the corners, it will be 1/8 into 8, 1 particle. At a face center, half into 6, it will be 3 particle, total 4 particles. So there are 4 particles carbon. That means N equal to 4. For a close packed system, if N equal to 4, number of tetrahedral voids is 2N. Number of tetrahedral voids, it will be 2N, that is 2 into 4, 8. And number of octahedral void, it is N, that is 4. So this is the number of tetrahedral and octahedral void. And we have A atoms occupy 1/8 of tetrahedral void. So A is available in 1/8 of tetrahedral void, 8. So it is 1 particle. And B is available in half of octahedral void. Half of octahedral void. So it will be 2 particle. So A is 1, B is 2 and C is 4. A1, B2, C4. A1, B2, C4. Option A is the correct answer. Right? That is some typical classic example questions regularly coming for all exams. Through this video, we are experiencing those 3-4 questions with some good content in it, and all are requested to practice similar kind of questions, right? We will meet with another video and some another beautiful questions in the next one. Okay, bye, see you, take care.